And this is how to solve rate problems from John Linneball Tutoring. Rate problems are things you will find frequently on the SAT, the ACT, the GMAT, and the GRE. So they're common standardized test problems. Now the distance formula is simple in that distance is just equal to the rate times the time, or D equals RT. For example, 60 miles equals 60 miles per hour times 1 hour. So you can figure out the speed if you know the distance and time. If you drive 60 miles in 2 hours, you are driving 60 miles over 2 hours, which is 30 miles per hour. That is, the rate equals the distance times the time. The time can be figured out by dividing the distance by the rate. The time is equal to the distance divided by the rate. And for example, you can drive 90 miles at 60 miles per hour in 1.5 hours. So you just divide 90 by 60 to get 3 over 2, which is the same as 1.5. Now the formula itself is simple, as we just saw, but some problems are hard. While most of the problems that are basic manipulations of D equals RT are easy, test makers can make really hard problems using that formula and maybe some other simple math. Here's a sample problem. Fred drove to a work assignment from home in 2 hours. Because of traffic, Fred had to drive 20 miles per hour slower than the speed he drove to work, so his trip home along the same route took 3 hours. How far is it from Fred's home to the job assignment? Well, we know the distance is equal to the rate that Fred drove at times 2 hours, and it's also equal to his rate minus 20 miles per hour, that is 20 miles per hour slower than his morning rate in the afternoon times 3 hours, because it took him 3 hours because of traffic to get home. So we know that the distance is equal to the rate times 2 hours, and the distance is equal to the rate minus 20 miles per hour times 3 hours. Again, because he drove to and from the job site over the same route, so there's no trick there. He didn't find a shortcut in the morning, but he couldn't take it in the afternoon or anything like that. It's obviously the exact same route. So the distance is equal to R miles per hour times 2 hours. So these hours will cancel out, and R minus 20 miles per hour, you can see over hour and hours, those will cancel out as well. So we end up with 2 times R miles equals 3R miles minus 60 miles. If we combine like terms, we end up with 3R minus 2R miles equals 60 miles, so R is equal to 60. Substituting 60 in for R, we get D equals 2 times 60 miles, which is 120 miles, and the rate that he drove in the morning is equal to 60 miles per hour. So Fred's work assignment was 120 miles from his home, the answer we needed, and we can also see that Fred drove 60 miles per hour to the job site and 40 miles per hour home from the job site if we needed to answer that. So, yabba dabba doo! All right. Work problems. No, this isn't a human resources video. This is just an explanation of the fact that the same formula can be written as work equals rate times time instead of distance equals rate times time. Let's say you have a human being or an animal or a machine that works at a more or less constant rate. You can figure out how much work that person or thing can do in a given amount of time if you know the rate. If you know how much work they did over a given time period, you can figure out the rate. So you'll probably see it as something like this. Bob can shovel snow from a parking lot in 90 minutes. His brother Doug can shovel the same lot in 80 minutes. You cannot. You lie so bad. Take off, you hoser. All right, anyway. If Bob and Doug work together at their respective rates, how long in minutes will it take them to shovel the lot? First, let's set the work W equal to one job, in this case, one parking lot. So W equals RT becomes one lot equals RT. Since we know Bob can shovel a lot in 90 minutes, we know that one lot is equal to R times 90 minutes, and Bob's rate is going to be equal to one lot over 90 minutes. Using the same method, we see that Doug's rate is one lot over 80 minutes. So how do we figure out how fast Bob and Doug can work together? It's actually pretty simple. Set up the same work equals rate times time equation as follows. One lot equals the rate times t minutes. In other words, Bob and Doug shoveling the same lot, each working at the same rate they would if they were working alone. So it would be one lot equals Doug's rate plus Bob's rate times t minutes. So we need to find the time. Using basic algebra, we see that t minutes is equal to one lot over 80 minutes plus one lot over 90 minutes. See, this is Bob's rate and this is Doug's rate, 1 over 90 minutes. And since we have to divide the work, the one lot, by the combined rate to get the time, this is the formula we have. So what do we need to do next, class? That's right, find a common denominator. So we have one lot over this rate and this rate, but we have to find a common denominator before we can add them to figure out what that rate is. So we can factor 80 into 2, 2, 2, and 10, and 90 into 3, 3, and 10. Yes, I know we could factor the 10 into 2 and 5, but we don't have to. So we can see the only common factor in the two denominators is 10, and so we have to multiply 1 over 90 times 8 over 8 and 1 over 80 times 9 over 9. So we end up with 1 over 80 becoming 9 over 720 because we multiply by 9 over 9. We're just changing the expression. We're not changing the actual value. 1 over 90 times 8 over 8 gives us 8 over 720. And the total rate is going to be 17/720ths of a lot per minute. Dividing one lot by 17 over 720 lots per minute, the lots cancel out, minutes become 1 over minute, which is just minutes. So we end up with 720 over 17 minutes, which is about 42.35 minutes if you plug it into your calculator. Don't believe me? Fine. I'll do it right now. Jeez. All right. See? Happy now? Okay. Now you believe me? Good. So note that you could have also done this probably faster and more easily by converting the minutes to hours, which would have made 80 minutes into 4/3 of an hour and 90 minutes 3/2 of an hour. Those are certainly easier fractions to work with than 1 over 80, 1 over 90, and 17 over 720. So then Bob's rate would be 1 lot and 3/2 of an hour, which is 2/3 of a lot per hour. Doug's rate would be 1 lot and 4/3 of an hour, which is 3/4 of a lot per hour. So 2/3 plus 3/4 is 8/12 plus 9/12, because it's 2/3 times 4 over 4, and 3/4 times 3 over 3 converts it to the lowest common denominator, which is 12ths. And so you end up with the total rate is 17/12ths of a lot, or lots per hour. So the general formula for 1 over a plus 1 over b, by the way, is a plus b over ab, because 1 over a, you could multiply that times b over b to get a common denominator with b, so you end up with b over ab, and 1 over b times a over a equals a over ab, so their sum is going to be a plus b over ab. So that's what you could have done with the 1 over 80 and 1 over 90 if you knew this, but you didn't, did you? Ha, well, now you know. Anyway, finishing the problem at hand, the time would be 8 over 12 plus 9 over 12, which is 17 over 12's hour to do one lot. So the rate would be approximately 1 over 17/12, which is 12 over 17's lots per hour, which is approximately, or hours per lot, I should say, or approximately 706. So we should change that to hours per lot. Approximately 0.706 hours. So if it were a grid-in problem, you could just grid in 0.706, right? No, you could not. Or 0.71, no, because you have to pay attention to the units. Since the problem asked for the time in minutes, you have to multiply by 60, so the result is again 42.35 minutes. On a multiple choice test, they could put both 0.706 or 12 and 17 and the correct answer of 42.35 as answers if they wanted to know how many minutes it would take. So you want to make sure you know in what units the answers are supposed to be. All right, hope this helps. Have a nice day. Talk to you later.